Welcome everybody to our webinar today on Precoat Filtration. I can see that we've got a few people that are still in the process of logging on, so we're going to give it about one more minute or so before we get started, so thanks for your patience. Okay, welcome everybody to today's webinar. My name is Jill Browning and I will be your moderator for today's webinar on Precoat Filtration 101. Before we get into our presentation today, I do have just a couple housekeeping slides to go over. First of all, hopefully you should all be hearing me now. But I do want to just briefly mention that should you have any difficulties throughout the presentation today with your audio, there are two different ways to connect. You can connect through the computer or through the phone line, so feel free to switch back and forth if one should stop working for you for any reason. And also, due to the large number of attendees that we have on today's presentation, we have gone ahead and muted everybody's line. But no worries, you still can interact with our speaker. And in terms of interacting with our speaker today, you can ask your questions via the questions panel over to the right-hand side anytime throughout the webinar. And at the end of the presentation, we do have some time set aside for questions. So feel free to ask our speaker any questions that come to mind. And we will try to get to as many of those questions as possible as time allows. We have gone ahead and made our collection of on-demand webinars that we've conducted over the last couple years available to you. Feel free to check those out. They are published over at www.veoliawatertech.com. So feel free to go over, check those out, and register for any of those that may be of interest to you, and you can watch those at your convenience. One other housekeeping note that I do have is we are offering a PDF participation certificate. It will be made available to you at the conclusion of the webinar, and you should receive that within 24 hours or so after today's webinar. Also, one other quick note is at the end of today's webinar, you will receive a quick survey requesting your feedback. It shouldn't take more than 20 or 30 seconds of your time. And for those of you who do complete that survey, you will be entered into a drawing for a chance to win a $25 Amazon gift card. So if you are the lucky recipient, we will follow up directly with you at the conclusion of the webinar today. Okay, I've got just one more quick slide before I introduce our speaker today. Veolia Water Technologies. We are a leading company within water treatment. We focus our efforts within three key main areas. Technologies, we offer advanced and robust water treatment technologies. We have a large portfolio of over 350 proprietary technologies that we're able to offer to our clients. In addition to our technologies, we are able to pair those technologies in terms of developing projects for our customers and put together multiple technologies to meet the required treatment specifications of the clients. And then last but not least, we have a very thorough service offering that we are also able to provide, whether that's during projects or after. Okay, so now I'd like to introduce our speaker for today's presentation. Kim Fernandez is a process engineer at Veolia Water Technologies. Kim graduated with a BS in chemical engineering from Texas A&M University and has previously worked as a process engineer at a petrochemical plant for over 7 years before joining Veolia. So with that, I would like to turn it over to Kim.
Thanks, Jill. Hello, everyone. Today's presentation is about Veolia's Precoat Filtration technologies. We'll first look at the filtration spectrum. We'll look at what Precoat filtration is, the various types and configurations and how they work. And at the end, we'll go into some of the applications and case studies. So first, let's start with the filtration spectrum. This is the filtration spectrum chart, and on top you can see it's in micrometers. So these sizes, so we have the sizes on top first. The micrometers is also known as microns, and these are the common materials that are arranged according to their sizes. So for example, human hair and mist are about 100 microns or so. So this is for a good understanding of the micrometer sizes for various common materials. Also at the bottom, you can see the various separation processes that are used for each of the sizes. Precoat filters and other particle filtration technologies can filter materials above 1 micron. Now let's take a look at what precoat filtration means. Precoat filtration is a solid liquid separation process that uses a filter element that throughout this presentation I'm going to be referring to as leaves. Precoat, also known as filter aid, is deposited on top of the leaves that create a layer that allows for fine filtration. Some of the examples of filter aids are diatomaceous earth, or DE, cellulose, or perlite. If you look here, this is a cutaway of leaves that are used in Veolia's Precoat filters. You can see that the leaves have metal screens on the inside and either a cloth or a metal screen on the outside. The Precoat is first added to the filter, and the Precoat materials wedge themselves, creating a layer on top of the wire or the cloth screen. The thin Precoat layer is permeable and can allow water to go through while filtering out any of the solids. Also, you can see that the pre-coating allows for finer filtration, which would otherwise not be possible to do with just the leaves. Sometimes during service, depending on the filter run length that is needed, filter aid is also added to the feed or the inlet liquid and is called body feed to maintain the permeability of the filter cake. This is a microscopic view of the filter aids. This is DE, perlite, and cellulose. DE is made of amorphous silica and is mined from various deposits, crushed, and then heated to create an inert filter aid that is powdery, but is robust and porous. You can see the porosity in the picture here. Perlite is mined from volcanic rocks and is crushed and then expanded, kind of similar to popcorn, which creates these small openings that you see here. This again gives it its porosity. Cellulose is basically plant fiber that is made from wood pulp and shavings. The small fiber size means there's a lot of void space in between, which makes it a great filter aid material. You can see that the reason why these filter aids are so effective is because they're all porous, and the openings in them can allow the liquids to permeate through while they keep out the solids. Now let's take a look at the filter leaves. As we saw before, filter leaves can have metal or cloth surface on top that can build up a pre-coat layer on top of it. There are various types and materials for the leaves. First is the metallic laser welded leaf, which is the one you see here. We also have the single U, or the cloth or metal outer screen. Earlier in the cutaway, you saw this example. We can also do non-metallic FRP screen, which is mostly used for corrosive applications. There are also different designs of leaves. For example, if you look at the leaf here, this is a circular center discharge, meaning the liquid flows through these leaves into the center and is connected to a common discharge line. Or this opening can be at the bottom, and it's called the circular bottom tube discharge. Sometimes the filter type is different, so the shape of the leaf can be rectangular, and the design is then called the rectangular bottom discharge. One important thing to note is that these leaves, if operated correctly, have a very long lifespan, and even if the leaves are damaged, they can be repaired, as opposed to membranes that at one point you need to replace them. This ultimately lowers the operational expenses over the lifetime of the filter. So now that we've looked at some of the basics of Precoat filters, let's look at the advantages. Precoat filters can remove particles 0.5 to 1 micron in the liquid stream and reduce the total suspended solids down to less than 1 ppm for a wide range of applications. This is a fully automatic operation, meaning from pre-coat to filtration to cleaning the filters and swapping between filters are all done automatically. Because we have a pre-coat layer that is added on top of the screen, it protects the internal elements from fouling, which maintains the integrity of the leaf. Also, having a pre-coat layer on top means the leaves are kept clean because the cake is easily released during the cleaning cycle. The continuous addition of body feed, or the filter aid, also helps maintain cake permeability and helps with longer filtration cycles. Because a permeable cake is maintained all the time, the pre-coat filters do not blind quickly, and they can handle a variety of types of solids. Continuing on with the advantages, when compared to other filters, Precoat filters can remove large amounts of solids while maintaining a long filtration cycle. These filters also have a relatively lower capital cost, and these filters have been proven to be durable and robust, with a lot of our filters still in operation for over 30 years. Also, we've had many customers who've ordered replacement filters as their existing Precoat filters have been efficient for their plant, so they've ordered replacement. Depending on the application, the filter vessels and leaves are also available in a variety of materials. We have coated carbon steel, stainless steel, or even high alloy materials. It's also important to note that the Precoat filters can handle a wide range of pressure, temperature, and pH, and is usually only limited by the availability of the material. Also, if needed, these filters can be chemically cleaned with acid or caustic. Now let's take a look at the types of filters we have and how they work. So the first one you see here is the Autojet, or the rotating leaf filter. This is the Filtermatic, or the fixed leaf filter. And this is the Autoshock, or the candle filter. For this presentation, we're going to be focusing on the Autojet and the Filtermatic filter. The Autojet filter is a horizontal filter with cylindrical leaves that are placed vertically throughout the length of the filter. This is a fully automatic operation, and it can be designed for either a wet cake or a dry cake discharge. These filters are designed with easy leaf removal and installation for any maintenance or troubleshooting purposes. We have three types of doors, the auto lock, swing bolted, and the rotor lock. The auto lock and rotor lock have the quick opening feature. One of the main advantages of the Autojet leaf is its center discharge design. During filtration, the vessel is completely filled, and the circular design of the leaf allows the flow to distribute evenly. As you can see, all the outer edges are equally distant from the outlet. This allows for an even distribution of the precoat and even for the solids to build up. For cleaning of the leaves, the filter has a fixed top header with individual spray jets to clean both surfaces of each leaf. The filter also has a bottom sluicing to wash out any cake that fell. Also, you can see that during the cleaning, the leaves are rotated while the fixed spray header on top cleans the leaves. This allows for a fast and efficient cleaning of the leaves. This is the single conic and double conic design of the Autojet. You can see that the single conic has a sloped bottom on one side that allows the cake to fall and be washed out easily, and also it doesn't build up at the bottom. The double conic, you can see, has sloped bottom on both ends, and the cake is washed out at the bottom. The single conic or double conic design depends on the flow rates and the various filtration area that's needed for the filter. You can also see that the vertical leaves and the spray header on top with the individual spray nozzles. The Autojet filters are also designed for both wet cake and dry cake discharge. For the wet cake, the water is used to remove the cake off the leaves and they fall to the bottom where they're removed. For the dry cake, air is used to dry the cake and remove any moisture, and this allows the cake to fall to the bottom. And you can see the auger here is used to remove the solids. The style you see here is a trough type design. For the wet cake discharge, we have the vessel in both single conic, double conic, and also the trough type. For the dry cake, we only have the trough type with the auger at the bottom. Now let's take a look at how the Autojet filter actually works. First, let's look at the piping connections that are on the outside. That's the Precoat inlet and outlet. That's your service inlet and outlet. Now, as we make our way around the filter, note the sloped shell on both sides. This is the double conic type of Autojet. These filters are also provided with all the piping, valves, instrumentation, etc. That's the top and bottom sluicing. The motor is used to rotate the leaves during cleaning. The drain removes all the wet cake that fell to the bottom. This is the auto lock door that I mentioned before. It's a quick opening door. We also have other types of doors that can be provided. The entire system, we can put it on a skid, even though the skid is not shown here. This is a look at the internals of the Autojet. You can see the vertical leaves, the spray header, the individual spray nozzles. This is a look at one of the leaves. This is a laser welded metal leaf, similar to the one we saw in the beginning. Keep in mind, we also have leaves in various other types and materials, and they're all based on the application. Now let's take a look at the actual operating sequence of the Autojet. The precoat starts first. It fills the vessel, and the precoat is recirculated between the precoat tank and the vessel until you get a nice thin layer of precoat on all the leaves. And then goes into the service cycle, and you can add body feed to the service inlet so you can get a longer run length. The solids build up on the leaf until the filter reaches terminal DP. And once it hits terminal DP, the filter will be drained, like it's shown here. And once it's drained, the cleaning cycle can begin. So as you see, the leaves are rotated and the spray nozzles clean each of the leaves. You don't see here, but both sides of the leaves are cleaned here. The cake that falls to the bottom, and the bottom sluice washes it down to the drain. And that's how the Autojet works. The second type of precoat filter is the Filtermatic filter. Similar to the Autojet, Filtermatic is a horizontal tank with vertical leaves. The difference is that these leaves are rectangular, and during cleaning, the leaves remain fixed while the sluice header rotates to clean each of the leaves. For dry cake discharge design, we have a fixed vibrator to remove the cake from the leaves. Breech lock door design is the most common type of door for Filtermatics, but we do have other type of doors as well. The advantage of breech lock door is it allows for a quick opening of the filters. One main advantage of the Filtermatic is that the entire tank or the leaf bundle can be retracted either through like a manual station near the filter or automatically from the PLC. This allows for easy access to the filter leaves for maintenance or troubleshooting purposes. Also note that Filtermatics have larger flow capacity, which is needed for certain applications. This is another view of the Filtermatic. Here the shell is in the retracted position. You can see the inlet and effluent valve, the nozzles here. This is the hydraulic power unit that is used to open the filter bundle or the shell. In case you have a different type of door, you can also have a crankshaft that is used to manually open the door. You can see that these leaves are rectangular and are held in place. Remember that these leaves are kept fixed while the sluice header here rotates to clean the leaves. This is a photo of multiple Filtermatics that we have in operation. These are the two vessel configurations you have for Filtermatics. The first is the retractable bundle, where the door and the filter leaves retract while the tank remains stationary. And the second type is the retractable tank, where the leaves and the door stay stationary while the tank itself is retracted. One of the questions that our customers often ask us is about the sludge disposal options. And the sludge disposal options depend on the location of the operating plant as well as the composition of the solids that were removed from the filter. As you see from the chart, the sludge can be recycled into compost used for fertilizer or for other land applications. Spent sludge from various fermentation processes with no toxic contaminants can be a good medium for microbial growth, and this can also help with the nitrogen-carbon balance in the soil. Another way of recycling the spent DE is by mixing it with clay to make clay ceramic bricks. The DE that's added to the clay mixture reduces the density and provides a good insulation. For energy recovery, spent DE and sludge with cellulose can be used as fuel for furnaces. Also, sludge with biomass from like the food and beverage industries can also be sent to anaerobic digesters to produce biogas. That's shown here. The sludge before sending to landfill usually has to be dewatered, and the DE in the sludge helps dewater the sludge and reduces the volume and weight before it's being sent to landfill. We do want to let you guys know that we can also work with each and every one of you to help identify the sludge reuse options depending on the location of the plant and the soil contaminants. The Precoat filters that Veolia can offer are standardized products that can also be easily customized. You saw that we can offer various vessel materials and configurations depending on their process parameters. Currently, we have 1,554 Precoat filters installed all over the world, a majority of which are the Autojet filters at 1,096. We also have 240 Filtermatics, 139 Autoshocks, and 79 Vertijet filters. For the Vertijet filters, only filter replacements are offered, but no new filter installations. For the Precoat filters, depending on the customer requirements, we can provide just the vessel with the internals and the motor, or we can provide an entire complete package with the vessel, the face piping, instrumentation, valves, controls, etc. We can also do mechanical and electrical testing of the entire package. If you look here, this is a system that we provided recently. It has 3 Autojet filters. It has a Precoat and body feed tank, Precoat and body feed pumps, the filter aid handling systems. We can do either manual or automatic bag handling systems. And it was provided all in skids with interconnecting piping, controls, and complete with system testing. Since we have a large number of installations all over the world, we also provide an extensive spare parts and field service support. We have 7 dedicated aftermarket staff that can assist with the startup and any ongoing operational issues. When needed, we're also able to provide spares quickly as we have an established supply chain for all the filter parts. We also have stocked parts in our warehouse located in California, and all of this allows us to provide the client with competitive pricing and all the spares that is needed for them. We also have extended services that include on-site service visits, support with process optimization, and also provide virtual or on-site training for the operational personnel. Ultimately, our goal is to minimize production interruption and any downtime. Now let's take a look at some of the Precoat filter applications. These are the common applications where our Precoat filters are in operation. We have a number of installations in the metals and mining industries, such as gold and silver mining, soda ash, also in food and beverage industries like beer, wine, whiskey, for phosphoric acid, various juice processing, liquid sugar, pig hide gelatin, also vegetable oil. We also are in the chemical processing industries as the amine processing and catalyst removal industries. We also have pilot test units available to test any new process fluids, to determine various process parameters, and to test to make sure that the performance of Precoat filters for the new application. For example, we recently conducted a pilot test for a refinery. They wanted to remove carbon fines from their reused water stream, which was otherwise fouling their heat exchanges downstream. Now we'll go into some specific applications and the case studies for them. This is a schematic for the Merrill-Crowe process that is used for silver and gold processing. The process starts with crushing and milling the gold or silver ore. The gold and silver are soluble in weak solutions of potassium and sodium cyanide. So the crushed ore is allowed to leach or dissolve into the cyanide solution. After that, it is stored in a holding pond and then sent to the Precoat filters. The Precoat filters installed here are able to remove any suspended ore particles from the gold cyanide solution to below 1 ppm. I also want to point out the next step in the process is a vacuum deaerator, which is used to remove any dissolved oxygen in the solution, and we provide these also. This is the typical process characteristics of the gold solution that's sent to our Precoat filters. Inlet solids loading is usually between 50 to 500 ppm. Usually these applications use carbon steel vessels with 316 stainless steel internals. Both the Autojet and Filtermatics can be used here. We can provide just a filter or the entire package with body feed and Precoat systems. We can also provide a vacuum deaerator tower and the vacuum pumps for dissolved oxygen removal that you saw. This is a case study of a recent project that we did for a gold mining plant that wanted to expand their production and needed 7 new Autojet filters. This was for 6 in operation and 1 on standby. The total flow rate to the system was 13,750 GPM, which is about 3,100 cubic meters an hour. Inlet TSS was 100 ppm, and the temperature of the system was 180 F or 82 C, and the pH was about 11. The clarified effluent from the filters removed suspended ore particles to below 1 to 3 ppm and removed the particles that were above 1 micron. Next application we're going to look at is beet sugar. In the beginning, the beets are received, washed and sliced and sent through a diffuser where hot water washes over the sliced beet, thus absorbing the beet sugar. After that, the sugar-rich raw juice is purified by precipitating any non-sugar components in the juice. The Precoat filters that you see here remove any precipitated non-sugar components from both the first carbonation and second carbonation processes. The filtered juice from the Precoat filters is later evaporated and crystallized into sugar. This is the typical process information for the beet sugar or also the food and beverage industries. The flow rate and solids that come into the filters vary depending on the application. The outlet TSS is usually maintained at below 1 ppm. Various Autojet filters have been installed from 600 to 1400 square feet. And all of these filters are automatic. This is a case study for a project for a beet sugar manufacturer that needed to debottleneck their plant and expand their capacity. They had older, smaller capacity Autojets that were replaced with 5 new larger capacity Autojets. The flow rate to the system was 1920 GPM, or about 436 cubic meters an hour. Inlet TSS was 100 to 200 ppm, and the temperature was 220 F, or about 104 C. pH was approximately 8.8. The filtered sugar syrup that came out of the filters had suspended solids below 1 ppm, and the particles above 1 micron were removed. This is another case study. This was for a phosphoric acid manufacturer that wanted to replace their existing Autojet filter. The flow rate to this one was 80 GPM, which is about 18 meter cube per hour. The TSS was 0.3 to 0.5% solids that came to the filter. Temperature was about 194 F, or 90 C. And note the very low pH of 1 to 2. The filtered phosphoric acid had suspended solids below 1 ppm. Precoat filters are also used in the soda ash processing plants. These are 2 soda ash processes. The first one is soda ash from Trona mines. Here the ore is crushed, heated, and the resulting slurry is filtered through the Precoat filters to remove any suspended ore particles. In the second process, soda ash is produced from limestone and brine. And here the Precoat filters are used to filter out ammonium chloride that precipitated from the soda ash solution, and it's used for ammonia recovery process. For a typical application, the flow rate varies depending on each plant. Inlet TSS usually is from 20 to 500 ppm, and the outlet TSS is usually below 1 ppm. Autojet filters are usually used here with 600 to 1500 square feet filtration area. And most of the systems are automatic. This is a case study for a project that had 32 Autojets that were installed in 1962. Each of the filters had a filtration area of 1,000 square feet. Recently, they changed 16 of the Autojets. And they were replaced, and once they're commissioned, the remaining 16 are expected to be replaced as well. These are some of the other applications where Precoat filters are commonly used. The corn wet milling industry uses Precoat filters to decolorize corn syrup. The gelatin industry uses it to filter dilute pig hide gelatin. And the brewing industry uses it for their primary and polishing filters. And they also use it to treat water prior to the brewing process. If you see, all of the outlet TSS is below 1 ppm, and various sizes of Autojet filters are used for all of these applications. In summary, Precoat filters can remove solids above 1.5 to 1 micron with an effluent quality of suspended solids below 1 ppm. Precoat filters are able to handle high solids. You saw a case study where an operating plant had 0.5% solids. These filters can also handle a wide range of flow, pH, temperature, and pressure, and it's only limited by material availability. We also looked at the Autojet, or the rotating leaf filter design. We looked at the Filtermatic, or the fixed leaf design, and we also have the AutoShock or candle filters. We have over 1,500 installed filters all over the world, and many of them have operated for over 30 years, which gives us a great reputation. We also have years and years of technical expertise on Precoat filters, and we can provide on-site and off-site process and technical support. We also can provide aftermarket support for spares and field services. And with that, I will turn it back over to Joe.
Great. Thanks so much, Kim, for that very informative presentation. Just want to remind everybody, if you do have any questions, feel free to type those over in the questions panel. And with that, we do have joining us with the Q&A session today is Oscar Velastegui. He is the technology manager at Veolia Water Technologies, focusing on the Whittier filtration and separation technologies. He has over 25 years of experience in a variety of projects related to industrial and municipal water treatment, with intimate knowledge of process, mechanical controls, and systems integration of many technologies. And then his key focus areas of expertise are obviously in Precoat filtration and also oil water separation technologies. So with that, we will open up our Q&A session here. Let me see what we've got. Question in regards to the Merrill-Crowe process. How often do you clean the Precoat filter?
For cleaning, I would say it depends on the number of solids coming in. So a lot of times we see about 24-hour filtration cycle, so it'll be once a day of cleaning.
Okay. Another question that we've got here also is approximately how many pounds of solids are removed per pound of Precoat media?
I'll let Oscar take this one.
Yeah, no problem. I guess we probably can do a calculation on that, but generally, I guess the Precoat needed for the filter itself is about 10 pounds per 100 square foot of filtration area. So that you need to add every single time you filtrate. And then after that, we need to figure out the body feed ratio, and if it needs one. So typically we will have a 1-to-1 body feed ratio, meaning that if you have 50 ppm of solids coming in, then you will have 50 ppm of body feed injected into your feed to make sure that cake is permeable. It gives you a comfortable run line, or I would say something that the client would I guess agree in terms of run length and production goals that you need to have there. Okay.
Great, thanks, Oscar. Another question that came in is, can you talk a little bit about the advantages of these types of filters versus, say, sand filters?
I think it would be kind of the advantages that we went through earlier today. So those are basically the advantages on it. It doesn't blind quickly, which is one of our major advantages.
Yeah, something else also for between sand filters and Precoat filters. Usually a sand filter loading will be capped between 10 and probably 30 ppm maximum solids, and 30 ppm will be on the high side. Usually 10 ppm is sort of a standard. The other thing is that the micron size that you're removing out of a sand filter, it will be on the 10 micron range versus the Precoat filter that is 1 micron. So Precoat filters really give you a very fine filtration and a high loading capacity. So it's the two extremes of a media filter, which you cannot put a lot of solids and it doesn't filtrate as fine for many different applications where you need lower than a typical 10 micron size removal particle, which media filter usually give you.
Great, thanks. Is there a way to save the raw liquid instead of draining it during cleaning?
The raw liquid can be recycled back to the feed tank, or it can be pushed with the with air or any gas to the filtrate tank. Bottom tube discharge that we saw earlier, those leaves can be used with a heel drain nozzle, which can be used if you want to save the raw liquid.
Great, thanks. I believe we talked about this a little bit earlier as well, but if we want to just reiterate or talk about this again, another one of the questions that came in is, does the DE or perlite need to go to the landfill?
I don't think you can actually separate out the DE from the solids that are removed. So the sludge on its own, you don't have to put it to landfill. We showed you a bunch of other disposal methods. So depending on the contaminants that are in the sludge, you can reuse it or use it for energy recovery. You don't have to use it just for landfill.
Great. I think we've got time for maybe a couple more questions here before we run through our allotted time. For what reasons are access to the filter leaves needed, and how frequently would that be?
I think that would depend from application to application or from plant to plant. It would you wouldn't need access to the leaves often. You would just need it if it fails or if you need to take a look at it because the performance has gone down, or those kind of reasons for mostly maintenance and for like troubleshooting any problems you have in the field. You don't need to take it out periodically for anything.
Great. And Oscar, maybe this one is best for you. We didn't get into any oil and gas today with the Precoat filtration, but maybe you can talk, there's a question a little bit about our oil and gas industry expertise or experience. Maybe you can talk a little bit about that as well.
Sure. So some of these filters, I guess now with some need to re-inject this water and going into some tight formations. They require finer micron removal, better than what a typical media filter or a walnut shell filter would do, which will typically be 10 microns or a little bit below that. But what oil fields are requiring at this point is a micron removal of 3 micron or 1 micron or even below. There's where this filter, I guess, has the ability to be used for that application on the oil and gas market to provide a finer removal than what you have right now, so that water can be used to re-injection and not plug the wells.
Great, thank you very much. With that, we've actually run through our allotted time here, so we will conclude our webinar for today. But I do want to remind you that if you would please take a brief moment to fill out that survey as soon as the webinar concludes, that would be greatly appreciated. So we do thank you very much for your time today. And one thing I did forget to mention at the beginning of today's webinar is this has been recorded and it will be sent out to you within the next 24 hours or so as well. So with that, that concludes our webinar today, and we thank you very much for your time. Thank you.